Hello everybody. So today we are going to discuss about rapid and approximate analysis of building frames. So in the previous classes we have discussed about the plastic analysis of structures. So today if we see around us, almost all the major buildings are framed structures. And when we see buildings exceeding 2 stories, we normally adopt load-bearing wall constructions. And when the buildings exceeds 5 stories, we go for computer-based analysis procedures for analysis. And these approximate analysis or approximate methods of analysis are useful for us or helpful for us for analyzing the building frames up to 5 stories. Okay, so when the buildings are less than or equal to 5 stories, we go for approximate methods of analysis procedures. And in rapid methods, it is comfortable to treat vertical loads and horizontal loads separately. Now, let us discuss how to analyze the vertical loads. How to analyze a structure subjected to vertical loads. So whatever be the number of stories, it is customary to analyze only a part of the frame, and that part of the frame we call as substitute frame. So we don't analyze the structure as a whole. Suppose you have this is a 3-story 3-bay frame. So if we need to analyze this frame, sometimes we may take this part, that is the second story of the building. So this part, and we will be analyzing this part. So this is called substitute frame. So this part can be approximated as like this. So we call this as substitute frame. Now let us discuss the procedure for substitute frame method. So this substitute frame method is also known as two-cycle moment distribution method. So we have already learned in our previous semesters what is moment distribution method. So here we call it as the substitute frame method is also known as two-cycle moment distribution method. As we all know, for moment distribution method we will do number of iterations until we get a closer result. But here we go for only 2 cycles. That is why it is called a 2-cycle moment distribution method. So whatever may be the iterations, we stop with the 2 cycles. That is why this is called approximate method of analysis. And in this 2-cycle moment distribution method, we terminate the iteration or iterative process after 2 carryovers and 2 balancings. And suppose we need to analyze a 5-story 3-bay building frame. Let us assume that we are having a 5-story 3-bay building frame. And if we need to compute the bending moments on the beam on the 3rd floor level, we can substitute the 5x3 panel frame by a simplified frame. Simplified means we call it as substitute frame. Okay, so here you can see this is a 5-story 3-bay frame. Okay, so the 3rd floor, this. So the 3rd floor can be substituted like this. Okay, M, N, P and Q. So the columns, it is assumed that the far ends of the columns are fixed. So this is called substitute frame for this 3rd floor. Now, let us see what are the different loading cases we consider while analyzing while doing the approximate methods of analysis for vertical loadings. So when we design beams, the main consideration is the bending moment. So the span bending moments are usually sagging, that is tension at the bottom. Okay, when we take a beam, when we take a span, the span bending moments are normally, they are sagging because we have tension at the bottom. And the support bending moments. So if you have a support, so if we consider a fixed support, at the support we have hogging bend. At the supports we have hogging bending moments. Okay, so that means at the support you will have tension at the top. So in the span we have tension at the bottom, and in the support we have tension at the top. Here tension is at the bottom. Okay. So the span bending moments are usually sagging, that is tension at the bottom, and the support bending moments are invariably hogging, that is tension at top. And when we consider the bending moments, we consider three different types of moments. One is a span moment, second is a support moments, and the third one is column bending moments. See, because when we take a multi-story, multi-bay framed structure, so it is necessary to analyze the span moments. That is span. See, this is a span. This is another span. This is another span. So on every span, we have to see what is the moments. Then we have supports. This is one support, supports everywhere, right? So at each supports, what is the moment? Similarly, in the columns, we have columns. So in the columns, what is the bending moment? So first one is span moments. That is, in the span, if you take a beam, in the span, what is the moments? So for arriving the critical mid-span bending moment in any given span, we have to choose the position of live load to be at the most adverse location. See, why we need the knowledge of live load? Because everywhere the dead load is acting. Everywhere in the uh, frame, your dead load acts. So the maximum bending moment, it depends on the position of live load, where the live load is acting. Okay, so for this, in order to understand the position of live load where the maximum bending moment occurs, we need to understand the concept of influence lines. Okay, as I told you, dead load will always be present in all these spans. Now let us consider the influence line diagram and the critical loading position for live load. So the condition for the span moments, when you are having a continuous frame, and for the span moments, we are now considering the span BC. So for this span BC, you will have the maximum moment when there is a live load in the span BC. Okay, so this is the loading, that is position of live load diagram to create the maximum positive bending moment at P. This point is P. So this one is dead load, that is, it is marked in black color. So dead load. So dead load is everywhere throughout the span A, B, C, D, E. Dead load is everywhere. But live load should be, see, when you we are considering the influence line concept, that is the moving load concept. So what happens when considering the maximum bending moment in BC? There should be live load in BC. Okay, so this is the condition for maximum positive bending moment at P, that is in the span BC. Now, the condition is, as I told you, there is dead load everywhere. there should be live load in the span under consideration, and there should be live load in all alternate spans, and span in consideration should be loaded. Okay, so this is the BC is the span in consideration, and here alternate span is DE. So DE also will have live load. So suppose this is our span and this is the span under consideration. We will have a live load here. So this is the next alternate span. This is the next alternate span. Here it is. So like this, the alternate spans, and in the span under consideration we will have the live loads. So these things we have discussed in our classes also. So once again, in order to have a continuation, I am telling you once again. Okay. Now the second is the support moment. Second moment is the support moment. So for the support moment, support is here, right? If you take a span, this is our supports, and in the support we will have tension at the top. Tension at the top of the support, which means we will have hogging at the support, hogging moment at the support. So for maximum support bending moment, the two spans adjoining the support and every alternate span must have live load. See, here you have A, B, C, D, E. If BC is our consideration, we should have, sorry, this is a supports, okay. So if support B is our consideration, we should have live load in AB, BC. So because these two are the adjoining spans of the support B. So we should have live load in AB and BC, and we should have live load in the alternate spans, that is DE. Okay, so we'll see that. So you can see here. So this that is the support B is our consideration. Position of live load to create maximum bending moment at B. So support B. So what is B? B is the support. So at support, what is the loading condition to have a maximum bending moment? So at B, we have two adjoining spans, that is BA and BC. BA and BC. So these two spans should have live loads, and the alternate span, that is DE, should also have live load. So this is the loading condition for obtaining the maximum bending moment at the support. Now the third type of support is the column support. So column bending moments. Column bending moments. So columns are, we know columns are primarily compression members, but the presence of bending moment cannot be ignored, and while designing the columns, the bending moment and thrust, they interact to produce high stresses in columns. Now you can see for the columns, that is here our column under consideration is BG and DN. BG and DN. So you can see here our column under consideration is, this is BG and DN. Okay. For BG, when you are considering BG, this is the influence line diagram for M1. So your moment is acting like this. So our bending moment diagram is this. This red dotted lines. Red dotted line is the live load, influence line for M1. Influence line for M1. And when considering DN, our moment is acting like this, M2, and this blue color line is violet color line. Violet color curve is the influence line for M2. So for columns, you have to consider the moments. What is the moment acting at the joint of the columns, and based on that we will be drawing the influence line for different moments. And the loading condition is for maximizing M1, that is at B for this column. Moment at this column, that is BG, our loading condition is A, B, C, D. See, this is A, B, C, D, E. So here we will have the live load in BC and the alternate span D. So for DL, for DN, so A, B, C, D and E. So Dn, it will be almost like this, right? So for Dn, that is anti-clockwise moment, we have anti-clockwise moment here. So here the loading condition is the beam CD, the span CD, you will have the live load and the alternate loads. So for the clockwise moment, you can remember it simple. For the clockwise moment, the right of the column you will have live load, and for anti-clockwise moment in the left of the column you have live loads. You can remember it like that, okay? So that's all the basics about approximate method of analysis or substitute frame method or two cycle moment distribution method. So in the next class we will move on to the problem. We will discuss about the problems. So thank you for today.